And last presentation for today is moving from trace gases to aerosols, and Xiaohua Pan from NASA GSFC.
Do you see my screen?
You can see the screen, but it's not currently in presentation mode.
Oh, let me try again. Do you see my screen again?
You can see the screen, but still not in presentation mode.
My presentation, somehow, because NASA has some restriction, so we do have some difficulty using Zoom. So let me do something. I will share with you a Google Doc instead. So can you share? Okay, let me send to the box where. Oh, let's see. I will send it to the chat box. Okay. So do you see that?
Yeah. So let me see. I can try to share.
Mm-hmm.
Okay.
Mark, if you would like, I could do that.
Oh, Nancy, yes, please, if you could.
Let's bring this to here.
You need to stop sharing first.
Okay, sure.
Thank you. Let me try and get to it now. Hopefully you can see that. Is it working?
Yes. Yeah, it's wonderful.
Okay, just tell me when to push.
Yes, it will be many pushes because I have animation. Anyway, hi everybody. It's nice to be here. The organization is, I think, is so good. Bring all the experts together. So it's my honor to be invited here to present our previous research to compare 6 global biomass burning emission data set present in the first day. So I will show the intercomparison focus on aerosols. Here list my co-author, they contribute to this study in different ways. This project was funded by various NASA fundings. Next, please. Yeah, before start, I want to set a stage. So as you can see here, which is a comparison from multiple model. The interesting thing is like this, model have different configurations. So for this multiple model project done by Maria Petrenko and Ralph Ken and Mianqing, they invite multi-model to participate this project. They use same biomass burning emission dataset, which is GFAD 3.1. So as you see on your left, and can you see the lower right corner? Lower right, yeah, which is the modest, colorful, yes, wonderful, which is modest average the biomass burning AOD from individual fire cases over 2008, and the rest panels are different individual models, which showing you the ratio of modeled biomass burning AOD to models. So when you see blue color, which mean model are underestimated. If you see reddish color, which mean model overestimated. So as you can see over globe as a glance, you see lots of blue color, which mean biomass burning AOD from most fire cases were underestimated in most model. Let's focus on the 2 Southern Hemisphere region as highlighted in the purple oval. So in this 2 region, thank you. In this 2 region, you can see, I highlight 2 models, but you can see 7 out of 11 models underestimated biomass burning AOD. It indicates that the underestimated AOD is associated with biomass burning itself. In this case, it's GFAS 3.1. Next, please. Yeah, so this motivated us for this study. So as you can see, biomass burning emission is a crucial input in atmospheric and biochemistry models. However, in the first slides I show you, it has been poorly constrained in many models in global and regional level. Next. Yeah, so the following presentation will, can you go back? Yeah, I want to show you the paper. Yes, yes. Yeah, back one slide. So the following presentation, I will show the result based on our 2020 paper published in ACP. So for objective this presentation, next please. So first I will compare 6 popular global biomass burning data set with focus on aerosol. Also, I will apply this biomass burning emissions to models. So investigate the sensitivity of a model, the AOD, to the choice of different BB emission data set beyond the conventional GFAT. Next. Yes, next. So hopefully we can provide some help tips for biomass burning developer and modelers. Next. So first, I want to give you a roadmap for this talk. So I will compare emission data set and then compare the experiment using this data set. And then I will provide some recommendation to improve biomass burning emission data set, also the aerosol modeling. So that in the end, if I have time, I want to extend to show you some investigation regarding variation of result in terms years model and biomass burning injection height. Next. Yeah, here is a 6 biomass burning emission data set we'll present next. So as you see, is categorized into 2. Is first row is next, yes. First is burnt area based, which is a GFAT 3.1, GFAT 4 plus modifier, and FIN 1.5. And the second category is a fire radiative power based, which is GFAS, QFAD, and the FEAR. I want you note that version number because some emission data set already have new versions. So this comparison only based on specific version. And the common feature for all these 6, you can see all of them based on modest fire product as the previous presenter showed. Next, please. And in this slide, I give you a detailed comparison of 6 BB emission data set. It's not complete comparison, but it is our understanding, like a comparison, for example, burn area based data set regarding how they get a burn area, or like how to get the emission factor. For the next column is the fire radiative power based, how they derive the emission coefficient and how they derive a FRP. Each data set have a different approach. Next. And now I want to start the comparison for 6 biomass burning emission data set, focus on annual total for 2008. Next. Yes. Here I show you 2 represented biomass burning data set. Left is GFAT 3.1, and the right is QFAT 2.4. GFAT, as I said, is a board area-based product and in a lower end of emission total amount, and QFAT is based on FRP in the higher end. As Kelly showed earlier, here I focus on biomass burning organic carbon because it is like a major component of PM emitted from fresh emission regardless of fuel type. And BB, you can see like biomass burning emission are everywhere with some hotspot. But they show discrepancy in spatial distribution and magnitude. Can you click? Yeah, click again. Say these two region, you will see like QFAD have a more coverage and a higher magnitude. Next, please. Yeah, in this southern hemisphere, we see QFAD again have a higher magnitude. So give you a sense of how different are they. Next. Then let's move on to the regional total. So as previous presenter show, we follow GFAT definition of a region, which are 14 regions. So this is a chart show the OC biomass burning emission for 2008 in each region. So in each region, you can see the color code, like blue is GFAT 3.1 and the QFAT is the orange-ish. Can you click? Yes, let's first look at the Southern Hemisphere Africa. Click. Yes, you can see the comparison. Obviously, QFAT is largest and FEAR is second. Next. Now let's move on to Southern Hemisphere. North Hemisphere Africa, which actually contribute most by Central Africa. Again, QFAT, FEAR are largest. Next. For the Boreal Asia, you can see again, and QFAT is largest, and GFAT is second. Next. Yeah, Southern Hemisphere, South America, QFAT, FEAR are largest. So overly, we can see the comparison over global, and globally QFAT is largest, and GFAT 4S in light blue is lowest. QFAT is about a factor 4 larger than the lowest. And in most region, QFAT 2.4 and FEAR 1.0 are larger, and for GFAT 4S is the smallest. Next. Now let's see the monthly variation. Next. Yes, so still these 14 regions, and I highlight 4 regions with large biomass burning emissions. You can see the 6 biomass burning data set show consistent seasonal variation. For example, let's focus on Southern Hemisphere Africa in blue, and Southern Hemisphere South America in red. So the peak season in September. Excellent. Yeah, the peak, like peak season, like the emission in each region are associated with the dry season and human activities such as agriculture residue burning, residue burning. Next, please. Yeah, next. Yeah, this highlight regions. Okay. Yes, good. Next. Yeah, so next I will apply the 6 biomass burning data set separately into one model. Next. Yes, so as you can see, I name experiment same as the biomass burning emission name, and the additional experiment I run is no biomass burning. So in this run, we can compare how much biomass burning contribute to the total AOD. And again, I want to emphasize, I focus on 2008. Next, please. Yes, so here is a simulated AOD. As you can see, the upper right corner is a MISA AOD for September 2008. You can see the hotspot in Southern Hemisphere as I highlight here. And next to it is no biomass burning run. Yes, showing the bias. When you see green color, which means lower bias, this table shows regional average AOD for MISA in these 2 regions in Southern Hemisphere. Next. And this table shows the averaged AOD bias in each model experiment. So you can, when you see green, which means lower bias. Next. Yes, so compared to like look at the bias in no biomass burning. So and compare the number to the total MISA. So you can see these 2 regions, biomass burning dominated total AOD. Next. Yes, it's a GFAD, 2G FAD. Next. And the FIN and GFAS next. Yes, thank you. So you can see the similar AOD is underestimated in almost all experiments. Yeah, you see green color. And the QFAD 2.4 and the FEAR have a less bias. Yes, next. So at this stage, you may wondering, like, which biomass burning emission data set did the best job in which region? Well, we will say it's a hard question we cannot answer with one simple strategy. So we will say each biomass burning emission data set have its strengths and weakness, but no one does best all the time over all the regions. So based on our case study showing in September 2008, in this biomass burning dominant regions, we found the simulated AODs with QFAD and FEAR, which have the most biomass burning emission, are the closest to MESA AOD and AeroNet. I didn't show here, but in the paper. And the second is a simulated AOD with a GFAD 4S, which has the lowest biomass burning emission, is underestimated most. Next. Yeah, now let's investigate why are the simulated AOD with QFAD and FEAR closer to observed AOD. These two are based on FRP. Here is a comparison each individual items. Based on the FRP, they calculated the PM emissions, use this equation as shown here, which is a CE in red is the emission coefficient time FRE. Yeah, for similarity of two of both QFAD and FEAR use a modest AOD to constrain CE for PM. So they have some advantage. And the difference is compared to QFAD, emission coefficient in FEAR is derived in more model independent way, not depend on JUICE model. You may know that QFAD is derived based on JUICE model. And also this CE vary with each grade, not depend on only one like biome type. Next. Yes, next. Yeah, then how can we improve biomass burning data set in future? So I will give some recommendation. Actually, many of them already mentioned in previous talk. I'm so happy, so I just want to reiterate. Please, next. Yes, let's look at these two images, which from Modis Aqua, and your left is January 1st, and right is second day. So as a highlight in the yellow box, you can see Modis actually. Oh yeah, let me add that. So all six model, all six biomass burning are derived using Modis fire product, as I mentioned earlier. So here we assume the fire burning conditions are similar in 2 consecutive days. So focus on the yellow box. You can see the fire detection were missed in the first day around the gap area and off nadir. And in the red box in the second day, so you can see the fire again were missed, but were there in first day. So it's again confirmed that the fire detection were missed over off nadir and gap area in Modis. Next. Now let's look at again the Modis Aqua. So here showing you fire count in Modis Aqua in North America, 2018 July. The box region and the number next to it is a sum of fire count in this region. So let's compare to the same region, same time, same month. Next, in years. So obviously, virs detect more fire. You can see the number next to the box. It shows that virs detect 7 times more fires. Next. So we recommend to improve fire detection techniques and retrieval of FRP and bird area product using higher resolution sensors and a geostationary satellite. Next. This image you already saw, but I want to make a point use it. So can you click? Yes, let's look at these two regions. These two regions are dominated by savanna and grass burning. So the blue color is GFAD 3.1. So and the light blue is GFAD 4S. So we expect the newer version, GFAD 4S have a higher emission, but it didn't happen. It's lower. Can you click? Yes, click again. Yes, we found that, and then we check the emission factor used in these two emission data set. Actually, they are different. For GFAD 3.1, for Savannah, they use 3.21, and GFAD 4S use 2.62 and lower. So I think this lower emission emission factor used in GFAD 4S partially contribute to lower OC emission in this region. And in Andrea 2019, they recommend number 3.0 plus 1.5. So we recommend to use this number in future. Next. Yes, next. So here we recommend to improve emission factor as well emission coefficient. Next. Yeah, besides
Sorry,
improve.
can I just interrupt just to say this is 20 minutes. So if you're about to wrap up, then it leaves time for questions, please.
Sure. Yeah, besides recommendation to improve emission data set, we will also recommend to improve aerosol model. For example, the ratio of OA to OC, and also constrain fire plume injection height. Next. Yes, here is a conclusion. So yeah, this is our conclusion. I want to read, but I want to go a little bit next and come back to this slides. Yes. So a little bit discussion about the variation of a year, because we only focus on 2008. As Wenfu showed, actually the variation, their variation, but the relative between the biomass burning data set are similar. About the, yes, that's it. I think I don't have time to show the injection height, but a little bit. Let's move on to injection height. Let's go. Move. Yes, next. Yes. Okay. Yes. Yes. So here I want to show you the emission injection height experiment we did, because it's also mentioned in previous talk. Is what we did is besides the base run, which uses model default emission injection height, we did another experiment in red, which we constrain the model is vertical distribution emissions with the Miser constraint. So what we found here, showing you the vertical profile extension coefficient compared to CLEOP in April 2008 over the fire source region. So we found that the biomass burning injection height emission with constrained by Miser have a better vertical profile. Yes, that's it.
Okay,
great. Can you go back
Thank
to
you.
conclusion?
And a very, concluded, and I think a good place to finish, because we haven't focused on injection height so much in this workshop, but it has been mentioned in some places. So I think a good place to bring the second day to a close. So we do have some time for questions. I don't see any hands or anything in the chat right now, but if anyone has any questions, please raise your hand. And okay, so I see there is a question from Fang Jun just in the chat. So Fang Jun, would you like to ask Xiaowa yourself, please?
It's a nice presentation. I was just a comment saying can show a comparison using the fire counts from MODIS and VS, and it's saying that VS get many more fire counts. It's because I think the footprint size from two sensors is quite different because VS has a higher spatial resolution. So you were definitely saying that VS can detect many more files, but I think it's not very comparable directly. I mean, by comparing like file counts from two sensors. Yeah, that's just a comment. Thank you.
Okay, thank you for your comments.
Okay, thanks, Fangjun. So Guido also has a comment. So Guido, it's quite a lot to read out. So
yeah, sorry, it's not really a question. I think, well, first of all, I think this is really cool to see all these different data sets and then nice constraints. This was more something I mentioned yesterday that we used Erica models to look a little bit into this issue as well, and we also saw that size distribution and precipitation, etc., are some things that sometimes can be relevant to optimize on top of the biomass burning emissions.
Yeah, exactly. Yes, based on Maria's project, they also compare different things. For example, mass extinction coefficient and like depredation. They found that these factors also contribute to the difference of model. Yes, good point. Thank you.
great, thanks, Guido. So if anyone else has any other questions, then there's still 5 more minutes. And Cindy left the comment that the deeper dive was very much appreciated to understand more the causes of the variability. So I agree, there is a lot to think about, and this has been great that we get all this information in the same place and discuss it in the way. I think the engagement's been excellent.
Yes, agree.
So I think if there's no further questions or comments, then maybe we can wrap up for today. And so I'd like to thank all the speakers for this afternoon. So Xiaowa, Deborah, and I'm very sorry, I have to check the schedule, and Wenfu, of course. And thanks to everyone participating. I think the level of engagement's been excellent, the questions and the discussion. And this is exactly it's more than what we were hoping for, I think, in putting together the workshop. Tomorrow, there will be 3 more presentations, which will look at more regional comparisons of the emissions, as well as something on mercury and POPs from Terry for HTAP. And then in the afternoon, of course, we have the breakout groups. We saw the questions earlier. They'll be shared again tomorrow when we start and before we go into the breakouts. And I think plenty of things to digest and to condense, and very much looking forward to seeing what the breakout groups bring together on those 3 questions. So with that, thank you all very much again, and look forward to seeing you all tomorrow at 2 p.m. UTC again. Thank you.
Thanks, everyone. Bye.